All right, so homework 37, we're simplifying a rational expression. Easiest thing to do to simplify this is, first of all, make it all just a multiplying. So anything in the denominator, we're going to move it up to the top, and when we move it up to the top, the sign is going to change. So if it's a positive, the exponent will be negative. If it was a negative, it changed to a positive. So this would be written as a to the 3/2 times a to the negative 1/4 times a to the, and instead of this being positive 1/3, we're going to make it a negative 1/3. Then we can use our rule when we're multiplying with the same base, we add the exponent. So basically we're just doing the adding and subtracting with our fractions, so we have to have a common denominator. My common denominator in this case, if I have a 2, a 4, and a 3, looks like I'd have to use 12. Making my equivalent fractions, 4 goes into 12. Oops, I've already did the first one. Now I got the wrong number up there. Do the first fraction. 3/2. 2 goes into 12 6 times. 6 times 3 would give me 18. Then 4 would go into 12 3 times. 3 times my minus 1 would be minus 3. And then 3 goes into 12 4 times. 4 times minus 1 would be minus 4. So I'm going to do 18 minus 3 minus 4, which would give me 11. So I get a to the 11/12 power. And since that's a positive exponent, I don't have to do anything else to simplify. If you're really bad with fractions, you could grab your calculator and do the adding and subtracting that way, but it's not that bad. So on the second one, same thing. This time we have two things in the denominator. We're going to move them both up to the numerator. So I'm going to have y to the 1/3 times, and then the next one would be
negative 1/4.
Y to the negative 1/4 times y to the negative 3/4. And again on this one, if I'm looking at my common denominator, it's going to be 12. So 3 goes into 12. 4 times 1 is 4. 4 goes into 12.
3 times negative 3.
Negative 3, and then 4 goes into 12 again.
3 times negative 9.
So 3 times negative 3 would be negative 9, right? So 4 minus 3 minus 9 would give me
Negative 8.
negative 8/12 then. Y to the negative 8/12. So we have a fraction. If I have negative 8/12, I can reduce that down, right? Negative 8/12 would reduce down to
2/3.
negative 2/3, right?
Negative 2/3.
And since my exponent is negative, what do I have to do to get rid of the negative exponent? Flip it, so I'm going to put 1 over y to the 2/3 power. Sneak that all in there, and that's what my answer is going to look like. Third one, same kind of thing. I'm going to move that up from the denominator. So I'm going to have a to the 5/2 times a to the negative 1/2 times a to the negative 1/3. And so my common denominator there would be 6. 2 goes into 6. 3 times 5.
15.
2 goes into 6 again.
3 times negative 3.
And 3 goes into 6.
2 times negative
2 times negative 1 is negative 2. And so 15 minus 3 minus 2 gives me
2.
10/6, which I can reduce down.
5/3.
So a to the 5/3 is going to be my answer since it has a positive exponent. All right, not so bad, right? Worst part is doing the fractions. The next ones, we're using the rule when we raise to a power. When I have b to the 2nd power and I cube it, my rule when I raise to a power is to do what with my exponents?
Wait, what was the question?
If I raise it to another power, what do I do with my exponents?
You add them?
Nope.
Multiply them.
Multiply them. When I'm multiplying, I add the exponents. When I raise to a power, I multiply this. So this would be b to the 6th power. B squared times b squared times b squared is b to the 6th. Same rule applies. We just have fractions here. So I'm going to take b to the negative 5th and raise it to the 1/5 power, and a to the 5/4 and raise it to the 1/5 power. So I'm going to multiply my exponents. When I take negative 5 times positive 1/5, what would I get? This is negative 5 over 1 times 1 over 5. What happens?
Is it going to be negative 1?
It's going to be negative 1 because the 5s would cancel out, right? So I could b to the negative 1. Or I could have multiplied and got negative 5 over 5 and reduced it down and still gotten negative 1, right? How about if I have a to the 5/4 raised to the 1/5 power? What am I going to get there?
1/4.
A to the 1/4 power. Because again, on this one, the 5s cancel out. We need to fix that one because we do have that negative exponent and we like to write it with only positive exponents. So how can I rewrite that answer?
A to the 1/4 over b to the 1st.
A to the 1/4 over b, and I don't really need to the 1st power, so just over b. So anything with the negative exponent, we move to the bottom to make the exponent positive. So number 5, same kind of thing. I'm going to raise to the 3rd power. So I'm going to take b to the 2/5 and raise it to the 3rd power, and then c to the negative 1/5 and raise that to the 3rd power. So if I take 2/5 times 3, I would get
B and 6/50.
b to the 6/5.
Oh, 6/50.
Keep in mind that the 3 is over 1, right?
Oh, okay.
So it'd be 6 over 5. And then I would get c to the,
3/5.
and my sign is negative, right? Since that was c to the negative 1/5. So c to the negative 3/5. And again, we have one that has a negative exponent, so we've got to rewrite our answer. b to the 6/5 over c to the 3/5. So number 6, again, we're raising to a power, so we're going to multiply our exponents. We've got c to the 1/4, and we're going to raise that to the negative 2/5. And then we got a to the 5th, and we're going to raise that to the negative 2/5. So 1/4 times negative 2/5.
Negative 1 over 10.
Negative 1/10. It'd be negative 2/20, which reduces down to 1/10. Or you could cancel the 2 and the 4 and reduce it first. And then we're going to have a to the
Negative 2.
negative 2. This again would be 5 over 1. The 5s would cancel out, so we just get a to the negative 2. Both of these have negative exponents, so how am I going to write my answer?
1 over A, 2, C to the 1/5.
And if you put the c first, it's okay. Since we have our commutative property, whatever order you put them in, but they like them alphabetically, so that looks prettier. So 1 over a squared times c to the 1/10. All right. 7, 8, and 9, simplifying some radical expressions. Square root of 45 is an irrational number. If you put it in your calculator, you get that big, long, crazy decimal. But you can simplify it by factoring it into something that has a perfect square. So when I think of factoring 45, I would factor 45 into the square root of 9 times the square root of 5. The reason I use 9 is because 9 is the biggest perfect square that divides evenly into 45. And then I'm going to simplify the part that's the perfect square. The square root of 9 is 3, and so I'm just going to get 3 times the square root of 5. You don't really need the dot in between, so we just put 3 square root of 5. So think of your numbers that are perfect squares. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. That's probably big enough. But those are the factors that you're looking for. What's the biggest one of these that divide evenly into my number? So if I'm simplifying the square root of 48, what's the biggest perfect square that divides evenly into 48?
8.
8's not a perfect square.
6.
6 is not a perfect square, right? It's got to be on this list I just wrote down of my perfect squares. So look at my numbers. Obviously 49 is too big. 36 to, 16. 16 times 3 is 48, right?
Oh, yeah.
So I want to write this as the square root of 16 times the square root of 3. Square root of 16 is
4.
4. So I get 4 square root of 3 for my answer. So it's always nice to have that little list of your perfect squares handy, so when you're looking at which factor do I want to use if I'm kind of stuck, I can just work my way up my list and say, oh, which one works here? So if I'm going to do the square root of 27, what's the biggest perfect square that divides into 27 evenly?
9 and 3.
9. So 9 times 3. So square root of 9 times the square root of 3. And the square root of 9 is
3.
3.
Square root of 3.
So we get 3 square root of 3 for our answer. Okay, that makes sense?
Yeah.
Alrighty. So on the next ones, we're going to add a couple things that you've done already. Last week with Jane, you did the square root of something with an exponent that was even. And so we're going to take the square root of 12 and simplify it, and we're going to take the square root of u to the 10th and simplify it. Square root of 12. Not a perfect square, so we need to factor that out. What times what should we make 12?
4.
4 times 3, right?
Yeah.
So if I do 4 times 3, the square root of 4 is
2.
2. So that would be 2 square root of 3. I still have to do the part with my exponent. The square root of u to the 10th is u to the 5th, because we do half of that exponent when we do the square root. They're going to put that back behind the 2 because it's a perfect square, so they're going to put 2u to the 5th times the square root of 3, and that's how my answer's going to go. So I'll just make one big square root and I'll factor it out that way. 28. What's the biggest perfect square that divides evenly into 28?
Four.
So 4 and 7. So I have 4 and 7, and then I still have the v to the 8th power. Taking out my perfect squares. The square root of 4 is
2.
2. The square root of v to the 8th would be
Beautiful.
v to the 4th, and then that square root of 7 is going to stay on the end because I can't simplify the square root of 7. So 2v to the 4th times the square root of 7. And so number 12, same kind of thing. I want to simplify this. 72 is not a perfect square. What's the biggest perfect square that divides evenly into 72?
9.
There's a bigger one than 9.
36.
36. So I'm going to say that's 36 times 2. If I would do 9, I would say 9 times 8, but then 8 would have to be factored again because that's 4 times 2. And then I could take out the square root of 9 and the square root of 4, which happens to give me the same thing as if I do the square root of 36. So if you find the biggest one, it just makes your work easier. So square root of 36 is 6. The square root of my x to the 6th would be x to the 3rd, and then I've got the square root of 2 left over. So 6x cubed square root of 2. So the last three, they're now going to throw in some odd exponents. When you have an odd exponent, such as s to the 5th power, to do the square root, you're going to factor out one of my variables. So I'm going to rewrite s to the 5th as x to the 4th times s. I add my exponents, 4 plus 1 is 5. Now I can simplify the s to the 4th part of it, which is s squared times the square root of s. So whenever you have an odd exponent, you're going to have that extra one left underneath your square root sign. So thinking about simplifying this whole thing. Square root of 50. 50 is not a perfect square, so I would factor it. The biggest perfect square that goes into 50?
25.
25. So we make that 25 times 2. Then we look. This one has an odd exponent, so we rewrite it as s to the 4th times an s. That one has an even exponent, so we leave it alone because it is a perfect square, t to the 12th. Now that we've got it factored out how we need it, we can go ahead and take out our perfect squares. The square root of 25 is 5. The square root of s to the 4th would be s to the 2nd, half of my exponent, and then t to the 6th. The 2 and the s going to stay underneath my radical sign, so I get 5s squared t to the 6th square root of 2s. So number 13, I'm simplifying this one, and what do you know about 36? "36 is on your list of perfect squares, right? So I don't have to worry about factoring that one. I'm going to leave that alone. It is a perfect square. The t to the 7th, however, has an odd exponent, so I need to factor the t to the 7th. How do I factor that?
T to the 6th times t.
T to the 6th times t. You're always just going to take 1 off of there, and then you have an even one. And then the u to the 10th has an even exponent. We leave that one alone. It is already a perfect square. So now when we take out our perfect squares, what are we going to have?
6t to the 3rd.
6t to the 3rd and
And u to the 5th.
u to the 5th are all coming out. And what do we have left under our square root?
T.
Just a t. So 6t cubed u to the 5th square root of t would be my answer. So on occasion, they're going to give you a number here that's a perfect square, and people think, oh, I got to factor it every time. No, you only factor it if it's not a perfect square to begin with. And number 15, 54 is not a perfect square, so we do have to factor that one.
Is it 9?
9 times 6. I know that's okay because 6 doesn't have any factors that are perfect squares, unlike when 8 did. So 9 times 6 would be our pair. Then we have x to the 11th. How would we want to redo that one?
X to the 10th times 1.
X to the 10th times an x. And then we have w to the 9th.
W to the 8th times w.
W to the 8th times w. So whenever they're odd, you're going to just take one out, and then you've got some perfect squares. So taking out our perfect squares, we can do
3x to the 5th.
3 square root of 9. X to the 5th is the square root of x to the 10th. And
W.
w to the fourth is the square root of w to the eighth. Whoops, and then I wrote an 8 instead of a 4. How about I write a 4 there?
3xw inside the square.
Whoops.
Wait. 2.
This is just going to stay
Oh, it's 6.
6. So 6xw. Can't do anything with those underneath. So we get 3x to the fifth, w to the fourth times the square root of 6xw. All right, that should be the next 5 things in chapter 6, which is that purple section there on your pie chart. We'll go ahead and work till about 10 and do the next page.